All right, now on to rationalizing. If you notice, 3 stars, that means it's important. It says, do not leave a radical in the denominator. If one is left, like letter B above, then you must rationalize the denominator by multiplying the top and bottom of your fraction by the radical in the denominator. So, by the radical in the denominator, this is our radical in the denominator, which means I'm going to multiply the top and the bottom by radical 7. Just like it says, multiplying the top and the bottom of your fraction by the radical in the denominator. Why am I allowed to multiply by radical 7 over radical 7? Well, that's because radical 7 over radical 7 is equal to 1. When we do this, we get radical 21 over radical 49. 21 does not have any perfect squares in it, so it has to stay radical 21, and 49 becomes 7. Multiply the top and the bottom on this next one by radical 3, because that's the radical in the bottom. We get radical 21s over radical 9. Again, 21 does not have any perfect squares in it, but 9 becomes a 3. Notice on both of these, the 7 and the 3 are no longer in a radical, which is the goal. So that's why it is solving our problem of having a radical in the denominator. All right, this next one I got to multiply by radical 2x, because that's the radical in the bottom. You do not need the 5, just the 2x. So I end up with 2x radical 4x, because what's inside the radical can multiply. And at the bottom, 5 radical 4x squared. To simplify this, 4 is a perfect square. 4 and x squared are perfect squares. X can't be broken up into anything else. So the 4 can come out front as a 2 and leave the x in the radical. At the bottom, you have the 5 out front, the 4 square roots to join it as a 2, and the x. And now things can cancel out. We got a 2x in the top and the bottom that can cancel. I believe that's it. So 2 radical x over 5. I believe, let's do one more. I was going to maybe stop there, but let's not stop. 5xy cubed is the radical at the bottom, so that's what we need to multiply the top and the bottom by. At the top, we get radical 15x cubed y to the 6th. At the bottom, we get 4 radical 25x squared y to the 6th. So now we break these up into perfect squares. 15 does not have any perfect squares in it, so it stays x cubed x squared times x. Y to the 6th would be y squared times y squared times y squared. Keep the 4 out front. At the bottom, the 25 is already a perfect square. X squared is already a perfect square. And y to the 6th can be broken up into 3. So all of these things are perfect squares. When we pull them out, we get x, y, 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 radical 15x. The bottom 4 times 5, x, y, y, y. Again, notice that the radicals are gone, and sometimes it's a good idea to start canceling now. 3 y's would cancel with 3 no i's. X would cancel with x. So we end up with radical 15x over 20. And that 15 and 20 are not allowed to reduce because they are not in both in a radical or both out of a radical. The top's in the radical and the bottom is not. So, hope this helps. Do the assignment at the bottom. Hand it in by the due date indicated on Google Classroom. If you have questions, email me or respond to a remind message. Thank you.